So what we're doing is linear inequalities now. Before when we did inequalities, and I wouldn't write this, but before when we did inequalities, we did things like x is less than 5. We only had one variable. We put it on a number line. Do we do an open circle at 5 or a closed circle? Open circle at 5. And we shade to the left. Because we know the x values are going to be smaller than 5, right? And if you're not sure, what you could do is you could say, well, pick a number for x. I'm going to say a 3. Do you agree 3 is less than 5? So 3 is part of the solution. So what you could say then is, well, where's 3 on the number line? 3 is going to be over here somewhere. So you have to shade the side that includes the 3. You have to shade the side that works. Is that fair? So new stuff today. I'm going to just start out by saying the steps. So what are the steps for what we're doing? And so I'll put a star by it for dramatic emphasis and say steps. The new stuff, instead of just having like a x is less than 5, we're going to now have an x and a y. It's kind of combining that we just looked at with like graphing lines. So the first step I'm going to say is graph the boundary line. So graph the boundary line. And so far that's mostly just doing what we were doing before with treating it like an equal. So I'm going to start out by saying treat like an equals to find location. So treat like an equals to find the location. So treat like an equals to find location. Now we're going to do an example, and that I think will really help. What I would do is I would leave 7 blank lines underneath this, and then write the example. So I'm going to scroll down, then kind of scroll back up. But I'd try to leave like 7 blank lines, and I'll have that on the screen again soon. But my example is going to be this here. So my example, we'll say graph y is less than or equal to 2x minus 2. So first step, treat that like an equal. So we're kind of pretending that this thing here is going to be a y equals 2x minus 2, and graphing like what that ends up being. So if we had a y equals 2x minus 2, we have several ways we could find the boundary line. One would be to go through and pick points for x, find y values. One would be to punch it in the graphing calculator, look at a data table. One would be to use the y-intercept and the slope. I'm going to kind of just go like the old way, and I'm going to say, all right, I'm going to pretend I have y equals 2x minus 2, and I'm just going to pick some numbers for x. So if I pick maybe a 2 for x, I'm going to take that 2, put it in right there for my x. 2 times 2 is 4, minus 2 is 2. So way too many 2's in the problem so far. But so we know one point that's going to go through is going to be this point right there, 2, 2. Fair enough? I want another point that's not going to be too close to that. I'll maybe pick like, I don't know. 8's going to, well, we could do, 8's going to end up being too high. I wouldn't write this if I were you, but if you put in 2 times 8 is 16, minus 2 is 14. So that's going to be over 8, which is right about here, but it's way up off my graph. So we know it's going to be like a line that's kind of going upwards like that. Fair enough? So maybe I'm going to pick something that's going to be back over in this range somewhere. So maybe a negative 2, negative 3. Anybody care? Negative 3. So if I take and do 2 times a negative 3, that gives me negative 6, right? So negative 6 minus 2 gives me negative 8. So barely squeezed it on my graph. So to graph that now, my negative 3 means go 3 to the left. Negative 8 means go down 8, so it puts me right there on my edge. And so right about there. Good so far? So now we just do a boundary line through that. I'm going to try to do a nice straight line. Hopefully it looks like it to you guys. Not too terrible. We do a line through those 2 points. We know that's going to be the boundary line. And that's kind of what we were doing earlier in this chapter. Agreed? Now, if I jump back up to my notes, up here, treat it like that to find the answer. Well, if we go to what we were looking at before, and I wouldn't mess up your notes with this, when we had a x is less than 4, that was an open circle at 4, right? We didn't include that in part of the solution. When we had a x is less than or equal to 4, then we'd have like a filled-in circle at the 4. Agreed? All right, so then if we have our boundary line here, if we have a greater than or equal to, or a less than or equal to, it's going to be a solid line. So in the example we just did, I had a less than or equal to, so I did a solid boundary line. It's the same sort of thing as what I had right here, less than or equal to. It includes that endpoint. So where this one included the 4, in my example down here, it's going to include that blue line as part of the solution. Now, if we were to have open circle one, so if we have an x is less than 4, we can't include that boundary line. It can't include that 4. So for those, we do a dashed line. So if you have a greater than or a less than, you do a dashed boundary line. So dashed line. Or you could say dashed boundary line if you want to. And that'll be the second example. We'll do one that's the dashed boundary line. So far, you feeling okay? Maybe a little bit unclear on the dashed. But now the only other thing we have to do is what we did in that first example. Figure out, do we take and shade over here to the left, or do we shade over there to the right? And I'd made the comment, well, pick a point that you know works, and then shade that side that works. It's going to be a similar sort of thing here, but I'm going to say this for finding the point. So shade one side is my number 2. So shade one side. So just like on the number lines, we had to shade either the left or the right. Now we need to either shade, in our example, above that boundary line and to the left, or below that boundary line and to the right. So to figure out which way to go, I'm going to say these 2 steps. So pick any point not on the line. So pick any point that's not on the line. And under that same thing, I'm going to recommend you go with 0, 0, if possible. If your line doesn't go through the origin, I'd recommend every time picking the origin because it's easy. It just makes the math easier. So if we jump down to our example, 0, 0 isn't on my boundary line, right? It's over there, just to the left of it. So if we take that original inequality, and I'm going to put in a 0 for x and a 0 for y. And you could do this with any point. You could, if you'd rather, you could pick some point over here, -3, 3. You could pick over here, which would be 6, 1. You could pick any point. But if you go with 0, 0, it just makes the math a lot nicer. So my left side is 0, is less than or equal to. My right side, 2 times 0 is 0. Minus 2 is -2. So when we put in the origin, we get this here. 0 is less than or equal to -2. Is that true or is that false? Is 0 less than or equal to -2? No. So if you're looking at a number line, you have your 0 over here. You have -2 is going to be down here somewhere. 0 is greater than, it's to the right of. So we know that the origin doesn't work, right? The origin isn't part of the solution. So if you know that the origin isn't part of the solution, then any point you check over here isn't going to work. Any point over there is not going to be part of the solution. So what you do then is you just shade this other side here. Because every point on the other side then would work. So try the origin. If it works, shade the side with the origin. If it doesn't work, shade the opposite side. Because you know then the origin doesn't fit, the other side would. At that point, you're done. I'm getting a couple people that are looking at me like I'm a little bit crazy, so I'm going to maybe do something like this. Do you agree this point over here, this green dot I'm putting on there, is part of the solution, supposedly? If you wanted to check that point, so if we had, instead of picking 0, 0, had picked, let's see, that's going to be 1, 2, 3, that's 4, 0. Agreed? My green dot is over 4 to the right, up 0. So we could have gone and put 4, 0 in our original equation. And when we do that, let me see if I can erase some of this. I can't. So if I were to put that 4 in for x, a 0 in for y, so I'd have 2 times 4 minus 2. Do you agree that's going to end up being 0 is less than or equal to 8 minus 2 is 6? 0 is less than or equal to 6. True, false? True. So because that green dot over here worked, then you know you could shade the side with the green dot. Does that make sense? So pick a point if it works, shade the side that has the point. Pick a point if it doesn't work, shade the side that doesn't have that point. All right, let's finish this off. So pick a point that's not on the line, and then I'm going to say indent a little if true. Oh, maybe I should say 0, 0 if possible. And so I'm going back up to the thing before, and put in the inequality, and put in inequality. So put it in that original problem. If it works out, if it's true, shade that side. You could say if false, shade the opposite side. So if it's true, shade the side that has that point. If it's not true, shade the side that doesn't have that point. I'm going to do a faster version of the graphing it just to kind of save a little bit of time. But if we have a y is greater than negative 2x minus 1. So the y-intercept is going to be a negative 1. Its slope is negative 2, so it's going to be something like this here. On your graph, if I were you, I would just take and make a line that's pretty steep that crosses y a little before the origin. But what kind of line do we do? Y is greater than negative 2x minus 1. So our line has to be dashed. Because it's not greater than or equal to, it's just greater than, you have to do a dashed line. So your line is going to be a dashed line, something like this. Try to make it look straight. At least when you do this eventually on like a quiz or a test, use a straight edge as you do your dashes. But we just need to figure out which side to shade. Should we try the origin, not try the origin?
Try.
Looks like the origin's not on the... If it's too close, then pick something else. But if you want to try the origin, put a 0 in for x, a 0 in for y. If I put the rest of this in there. So I end up with 0 is greater than negative 1. Is 0 bigger than negative 1?
Yes.
Yep. So we know that the origin works, so then you have to shade the side that includes the origin. If you weren't sure that the origin worked, you could pick a different point. Thank you for that. You could say, all right, what about this point here, like 3, 0? So you could put in a 3 for x, the 0 for y. You get 0 is greater than negative 6 minus 1. So 0 is greater than negative 7. Is that true? Yep, so then that red dot works. So then everything that's over on the same side as the red dot has to work. Good?